Have you ever wondered if our universe is real? Could everything we experience be part of an advanced simulation? From ancient Greek philosophy to cutting-edge quantum experiments, the idea that our reality may not be as physical as it seems has sparked debates for thousands of years. Today, science is shedding new light on these ancient questions, and the results are nothing short of mind-bending. In this video, we'll explore the simulation hypothesis, a theory suggesting that our universe operates more like a high-quality computer simulation than a standalone, physical reality. Through the lens of scientific experiments, philosophical debates, and the laws of nature, we'll journey to uncover whether the universe is a virtual construct. The debate begins in ancient Greece, where two opposing worldviews emerged: materialism and idealism. Democritus, the father of materialism, proposed that atoms, eternal, indestructible, and indivisible, compose everything. In this view, consciousness emerges from the physical processes of the brain, a stance that shaped scientific thinking for centuries. Plato, on the other hand, argued for idealism, claiming that abstract ideas, not physical matter, form the foundation of reality. According to Plato, every object we see is merely an imperfect reflection of its ideal form. For instance, a basketball is just an approximation of the perfect abstract sphere. By this logic, consciousness is fundamental, and matter arises from the mind. This age-old debate, whether mind creates matter or matter creates mind, remains unresolved. But recent scientific experiments may finally tip the scales. The materialist worldview faces a major challenge: the origin of the universe. The Big Bang Theory shows that space, time, and matter emerged from a singularity roughly 13.8 billion years ago. If the universe is all there is, how could everything come from nothing? The simulation hypothesis provides a compelling answer. Just like a video game booting up, a virtual universe starts from a zero state of information. Before the Big Bang, there was no space or time, much like how a virtual world doesn't exist until the program begins to run. Physicist Brian Whitworth has analyzed this idea in depth, comparing the materialist view of the universe with the simulation hypothesis. His conclusion? The data aligns more closely with the idea of a virtual construct. If our universe is a simulation, it should behave like one. And quantum mechanics, specifically the double-slit experiment, provides some of the most compelling evidence. Here's how it works. When electrons or photons are fired at a barrier with two slits, they form an interference pattern on the detector screen, as if they're waves passing through both slits simultaneously. However, when scientists place a measuring device to observe which slit the particle passes through, the interference pattern disappears. The particles behave like solid objects, creating two clump patterns. Why does observation change the outcome? The act of measurement forces the wave-like particle to decide on a definite state. This mysterious phenomenon aligns with the simulation hypothesis. In a virtual world, only the parts being actively observed are rendered into definite states, just like how a video game loads only the areas the player explores. Physicist John Wheeler took this a step further with the delayed choice experiment. In this setup, the decision to observe the particle is made after it has passed through the slits, but before it hits the detector. Astonishingly, the results show that the particle's past behavior, whether it acted as a wave or particle, depends on the observer's present choice. This suggests that time itself might not be as linear as we perceive. In a simulated universe, all events, past, present, and future, exist simultaneously within the program. The digital nature of the universe is another clue. In computing, everything is broken down into bits, smallest units of information. Similarly, the universe appears quantized. Light exists in discrete packets called photons. Electrons have a minimum possible charge. Even space and time seem to come in indivisible chunks. This aligns with the idea that our universe operates like a digital simulation, where everything is built from finite, computable components. In one of the most fascinating discoveries, theoretical physicist James Gates found error-correcting codes embedded in the equations of supersymmetry, codes identical to those used in modern computers. These strings of ones and zeros suggest that the universe might be programmed. What does this mean? If we're living in a simulation, these codes could be the software running our reality. Another groundbreaking idea is the holographic principle. It suggests that all the information in our 3D universe is encoded on a 2D surface, much like a hologram. This could explain why our universe behaves as if it's emerging from a deeper, underlying reality. Quantum experiments support this theory. For instance, physicists have shown that particles and fields behave as though they're part of a 2D system projected into 3D space. If the universe is a simulation, who or what is running it? Some theories propose that consciousness itself might be the programmer. Experiments like the double-slit and delayed choice suggest that observation, the act of conscious awareness, plays a role in shaping reality. Max Planck, the father of quantum theory, once said, "There is no matter as such. All matter originates and exists only by virtue of a force. We must assume behind this force the existence of a conscious and intelligent mind. This mind is the matrix of all matter." Skeptics argue that quantum effects don't apply to the macro world. However, experiments have shown quantum entanglement and wave-particle duality in larger systems, including molecules and even visible objects. Reality at all levels appears to follow the same quantum rules, reinforcing the idea that everything is interconnected. From philosophical debates to groundbreaking experiments, the simulation hypothesis offers a radical perspective on the nature of reality. It challenges the materialist worldview and suggests that consciousness might be the foundation of existence. If the universe is a simulation, what does that mean for us? Can we hack reality, reprogram nature, or unlock hidden potential? These questions remain unanswered, but one thing is clear. Science is blurring the line between physical and virtual, and our understanding of reality may never be the same. Whether or not we're living in a simulation, exploring these ideas pushes the boundaries of human thought and brings us closer to answering the ultimate question. What is our eel? So, what do you think? Is this all real, or is it all just code? Let us know in the comments below.